Alright, direct variation proportions. We need to look at this. The main thing is that each y value is the result of multiplying each x by a 7. So 1 times 7 is 7, 2 times 7 is 14, and so forth. And we write this equation right down here. Y equals 7x. Because if you plug it in, look, you get the y. If I plug in 7 times 2, out pops a y. I'll do green here. 7 times 3, out pops 21. So we plug. That's our equation. So let's look at some of these problems. Or first, there's some more. We write it without, it's y equals kx. There's no b. The line, looking at the graph, which some of us haven't looked at the graph, just know that I just erased where it starts. It needs to start at this point. Any graph that is directly proportional or direct variation starts right at the origin, and it's a straight line. So I'm going to just look at some. We're going to look at some, and you should hopefully understand. So let's look at this one. Does this start at the origin? You gotta ask yourselves these questions. Does it start at the origin? And the origin is right in there. And yes, check. So we can say the first one, there's two questions really asked. Does it start at the origin? Is it a straight line? That is a straight line. So yes, this is directly proportional. Direct proportional, okay? That one is. So yes, this is directly proportional. And one other thing, you could find the slope because from this, it's going up, it goes up 4 points here and over 1. So the slope is 4. We don't really have to worry about that right now. We'll get there, but just I want you guys to understand, is it proportional yet? Is this one proportional? Does it start here? Or go through that point, rather? And the answer to this one is no, because it doesn't start at 0, right? And we're going to find the slope here. The slope here is 7 because as you go down 2 and over 7. Again, I'm just showing you this. We don't have to worry about this. We're just trying to tell whether it is or not right now. If you were curious about the equation of the line, it is down here. Y equals negative 7x, 2/7 x plus 5. Determine whether this following table is an example of a direct variation. So is it proportional? Can we find some number? How do we get from there to there? Here to here. Here to here. Is there an example? Can we multiply by something? That's what we're asking. And it might, if it varies, then it's not correct. So the first one, we can multiply this by 7, is what that's saying. So negative 2 times 7 equals negative 14. So now let's look at 4. 4 to 4. 4 times 7 equals 28. So this is not, that's wrong. This is not proportional. So this is not proportional. It has to be the same number. So this is no, because it doesn't, it's not the same. If you, even looking at what it's increasing by, it increases by different values. It's very, you can tell that it doesn't have the same constant proportion. Now let's look at this one. Is there a number that we can multiply to get from there to there? Here to here. Or divide by. How are these numbers going? Start with one that you know. Oops. So, how do we go from here to here? And what are we doing? The answer is yes, because 1/5, we're dividing by 5. Right? Divide by 5. So, how do we write this equation? We would write this as y equals 1/5 x. Alright? Because it's dividing by 5. Dividing by 5. But the main thing is, just know that you can say there's a pattern here because every single time we divide by 5. Right? Every single time. -5 divided by 5 is -1. 15 divided by 5 is 3. Okay? That's the pattern. And that means it's, yes, proportional. Direct variation. We'll call it proportional. So, that's how you can tell. We want to look at this. I'm going to pause here and actually we'll look at this after.